So let's take a look at questions of this type when you are given something like sine x or cosine x or tan x, for example. So first of all, about this part, so as I told you, this is from AI, I mean, so it says 3 squared plus a squared, 5 squared, and a is 4. Guys, I do not appreciate this approach that much. Honestly, what I do is, if you just know the sign value of something, that doesn't necessarily mean this is 3 and this is 5. That means instead 3 times something like k can be something like a constant, so 3 times k and then 5 times k. Why is that? 3k over 5k, you just cancel these out, that's why it's 3 over 5. What I mean by that is that you can have a sign value of 3 over 5, but the length can be something like 12 and 20. I mean, do you know what I mean? So I don't want you to calculate it like this. So I want to see something like 3k squared plus blah blah is 5k squared. So just so you know, this is gonna be useful for you guys. So if my cosine value is 12 and this one 12 over 13, so my sine theta value is simply 5 over 13. But how is that? So basically my sine value is hypotenuse squared, which is 169, and then this one is 169 minus 12 squared, which is 144. Then my sine squared theta is 25 over 169, which is simply the square root, I mean, is 5 over 13. This is my sine value. So then my tan value is sine over cosine, then this is simply 5 over 13 over 12 over 13, which I'm gonna like inverse simply, then these will cancel each other out. So my tangent value is 5 over 12, guys. So let me see if there is a different type. Maybe this one we can solve this one. So because this one is basically the same thing, sine a and cosine a. So if tan a is this one, which is the same basically, the same question, so you can do it after watching this, and I'm sure most of you, if not all, have already completed these things. So let me see if this is an interesting question. If sine x is 8 over 17, determine the simplest whole number side lengths for a matching right triangle, then find cosine 10x. So if you know this famous angle, which is 8, 15 and 17, this triangle, so yeah, basically you can take it from there. It's easy for you, so I'm not gonna spend your time. So a right triangle has 10, 3, 4. So what I always do, guys, this is my angle, so 3k, 4k, and the hypotenuse is 30, guys. So 3k and 4k are my legs, then my hypotenuse is 5k. So 5k is 30, then k is 6. This is what I actually meant by that. So if my find both legs, so then short leg is, from that angle's perspective, I mean theta's opposite, I mean, is the short leg. It is 6 times 3, which is 18, and the long leg is 6 times 4, which is 24. That's it. So 18, 24 and 30. So we still have time, I guess. So I don't want you to feel obliged to watch this, because it's going to be a repetition of what I have done so far. So if cosine value is 7 over 25, find sine value. So again, so if I know cosine value plus cosine squared y plus sine squared y is 1, then this means 7 over 25 squared plus sine blah blah squared is 1. So you can take it from here as well. So I'm gonna continue here. So sine squared y is 1 minus 7 over 25 squared. So then sine squared y is 1 minus 49 over 625. So this is gonna be something like 625 minus 49, which is gonna give me here 576 over 620. What is this? This is sine squared y. So then if you take square root of this, then you will find something like 24 over 25, guys. So yeah, sine y is 24 over 25. I can show you one more thing. Maybe you wonder how I can simply find this, or maybe you think I simply read them from somewhere, but I don't do something like that. So what I do is I know the square roots of the terms from 1, 2, 3, 4. I know everything until 20. So I also know 25, and then I also know 30, let's say. So okay, 25 squared I know is 625. So but then there should be something like a number whose square is 576. Okay, so what is the difference between these two? It's 49. Okay, so then 25 minus 24 is 1, 25 plus 24 is 49. Then okay, then this one, the root square of the square root of this one should be 24. Okay, I'm gonna show you one pattern. So when you want to calculate things like me, not having to memorize every single one of them, which you can't, nobody can, I mean. So look guys, I'm gonna show you a pattern. So look at the difference between these two numbers. It's always 1. So the difference between the squares is like 576, and then this one is 625, and the difference is just the sum of them. And then if you move one more digit, then the sum again, which is 51. Then you're gonna add 51 to this term to find 26 squared. So add 51, and simply you have 675, if I'm not mistaken. So then you're gonna find 27, and the difference now is the sum is now 53, which means you're gonna add 53 to this one, and it's gonna give you 729, I guess. So and then 28, let's see, and this time you're gonna add 55. So every time you're gonna increase it by 2. Why is that? It's like x plus 1 is 2x1, and if you just take sum of the terms which are just 1 greater than those terms, like x plus 1 plus x plus 2, then it's gonna give you 2x plus 3. Every time you're gonna increase it by the addition by 2, guys. That's how I can simply figure things out. So like 28, then 858, so 55 to 729, it's gonna give you 784. So now again I'm gonna add 57 to get 29 squared now. So add 57, this one is 1, this one is 4, 841 if I'm not mistaken. And then 59, I'm gonna calculate it now. Yes, I'm correct, because I know this one, it's 900 simply. So look at the difference, it's 59, then it's correct. Look at the difference, it's 57, and it's correct. Look at the difference, it's 55. That's how I can figure it out quickly, guys. Sorry to bother you a lot with all of these, but they are not a must to know. They are good to know in terms of your abilities of like understanding the relationship between numbers, as well as describing them, being able to describe them in terms of each other as quickly as possible. Thank you guys. That's all for tonight.